Welcome to all of you again. In the last few videos, we are already discussing about the derivatives of inverse function. There are various types. We are already discussing 5 types of the derivatives of inverse function. Now continuing this process again, we have to discussing here another next type of the exercise 1.2, that is type number 6 of derivatives of inverse functions. Here we have to take the question number 9 from the exercise 1.2, that is differentiate the following function with respect to x. Here we are taking 5 examples of this type. These 5 examples are different from the example which I will be already discussing in the last few types. Okay, because in the last 2 types, that is type number 4 and 5th, the given inverse function having the f of x are in the form of again trigonometry function. Then we have to apply only the formulas of trigonometry and then we have to convert inverse trigonometry function. Okay, but in that type, the given inverse function having the f of x which are not in the form of trigonometry function, and therefore in this type, 6th type and 7th type, we have to convert the given f of x into trigonometry function by substitution method. In the theory part, we are already discussing some important substitution when the given function are in the typical form, then which substitution have to be applied, that have to be discussing in the second video of the derivatives of inverse function. By the help of this substitution, we have to convert the f of x in the given inverse function to the trigonometry function, and then we can find the simple form of the given function. Then we can get the derivatives of the given function. Okay, these are the important some substitution which are to be used to find out or to convert the given inverse trigonometry function having the f of x have to be converted into trigonometry function, and then we have to get derivatives of inverse function. Okay, student, now we have to discussing here the substitution method by the help of examples here. Okay, we have already discussed which are the some important substitution that we will be discussing. Now here we have to take first example of that exercise 1.2 question number 9, type 6th type, the given function in the form of cos inverse of into bracket 1 minus x square upon 1 plus x square, that is our given function. Okay, now we have to find the derivative of the given function. Here we have first to take the given function in the form of y equal to, now here if you have to looking, that is cos inverse of f of x, that f of x which are in the form of 1 minus x square upon 1 plus x square, and when you have to use, that is the function in the form of 1 minus x square upon 1 plus x square, then we have to use the substitution, that is x equal to tan of x, then it becomes, that is 1 minus tan square theta upon 1 plus tan square theta. Then we have to apply the formulas of the trigonometry, and therefore yes, which are the substitution put here, that is x equal to tan theta, then of course theta equal to tan inverse of x, and therefore y equal to cos inverse of into bracket 1 minus tan square theta upon 1 plus tan square theta. Now the given function here, the f of x have to be converted in our trigonometry function. Okay, and if the given function is the trigonometry, then definitely we have to convert that trigonometry in the form of, if the given function out of bracket is a cos inverse, then we have to convert that given function in the cos of f of x, and therefore we know that the formula, which is the formula, do you remember the formula? Yes, what is the formula? 1 minus tan square theta upon 1 plus tan square theta. Yes, that is cos 1 minus tan square theta upon 1 plus tan square theta equal to cos of 2 theta. That formula have to be applied here, and therefore here the given function becomes, that is y equal to cos inverse of into bracket cos of 2 theta. That means here we have to convert that 1 minus tan square theta upon 1 plus tan square theta in the form of cos of 2 theta. Now this is a simple function. Here cos inverse cos become cancel and only remaining is y equal to 2 theta. Now here we have to resubstitute the value of theta because the given function in the form of x, and therefore derivative have to be also in the form of x, and therefore y equal to 2 into the value of theta, that is tan inverse of x. Therefore y equal to 2 tan inverse of x. Now differentiate the given function with respect to x because we have to convert the given function in the simplest form. Okay. Therefore dy by dx equal to only applying the formula of tan inverse of x, and therefore 2 upon 1 plus x square, and that is the derivative of the given function, that is cos inverse of into bracket 1 minus x square upon 1 plus x square. Okay, do you understand? Okay. Now we are taking the second example of the same type, that is the substitution method. Taking the example, that is sin inverse of into bracket twice x into root of 1 minus x square. That is our given function. Okay. Take the solution. Firstly, we have to take the given function as a y equal to sin inverse of into bracket twice x into root of 1 minus x square. Okay. Now here you have to use the substitution because out of the bracket here is a sin inverse function, and f of x twice x root of 1 minus x square, that have to be converted in the form of sin theta. Then which is the formula which have to be used? Here if you have to substitute here x equal to sin theta, then here we get that is 2 sin theta into root of 1 minus sin square theta, that is 1 minus sin square becomes cos square theta. Then we can get 2 sin theta into cos theta, and that is, do you know, formula. And therefore here we have to substitute, that is x equal to sin theta, then of course theta equal to, that is sin inverse of x, and therefore the given function is y equal to sin inverse of into bracket 2 sin theta into root of 1 minus sin square theta. Okay, again only simplifying this, y equal to sin inverse of into bracket 2 sin theta into, now we know that the formula sin square theta plus cos square theta equal to 1, and therefore 1 minus sin square theta equal to cos square theta. Again here, that is square and square root become cancel, and therefore the given function becomes, that is y equal to sin inverse of into bracket 2 sin theta, again into bracket square root is a plus and minus, and therefore plus or minus cos of theta. Okay, now again simplify this formula. Here we can get, that is y equal to sin inverse of into bracket plus or minus 2 sin theta into cos of theta. Okay, here 2 sin theta cos theta is our formula, that is the formula nothing but the sin of 2 theta, and therefore the given function become, that is y equal to plus or minus, we have to take the plus or minus out of the bracket, that is plus or minus sin inverse of into bracket sin of, and then this is the simple form of the given
2 theta.
function. Here sin inverse sin become cancel, only remaining is 2 theta, therefore we can get y equal to plus or minus 2 theta. Now here only resubstitute the value of theta, that is y equal to, yes, that is plus or minus 2 sin inverse of x, and again only applying the formula of sin inverse of x, that is differentiate with respect to x, therefore we can get, that is dy by dx equal to plus or minus, okay, and that is the derivative of the given function sin inverse of into bracket 2x into root of 1 minus x square. This is the simple way, that means only here we have to substitute the perfect substitution, and by using the perfect substitution we have to simplify the given function in the simple form, and then we can get the derivatives of the given function. Okay, now taking the third example of the substitution method. of the type 6, the given function in the form of cos inverse of into bracket e raised to x minus e raised to minus x upon e raised to x plus e raised to minus x. Okay, that is our given function. Firstly, write the given function in the form of y equal to cos inverse of the given function f of x. Okay, now we have to use here the substitution, and which substitution have to be applied here, that have to be discussing here. Firstly, the given function f of x in the form of e raised to x minus e raised to minus x upon e raised to x plus e raised to minus x. That means we have to convert the given function in the form of trigonometric function. But firstly, we have to simplify the given f of x. Okay, then we have to apply the substitution here. Directly we cannot apply here the substitution. Okay, therefore firstly simplify the given function. Therefore y equal to cos inverse of, here only taking the e raised to minus x in the form of 1 upon e raised to x by the help of the laws of indices. Okay, again therefore the given function become y equal to cos inverse of into bracket e raised to x minus 1 upon e raised to x upon e raised to x plus 1 upon e raised to x. Okay, now taking only the LCM of the numerator and denominator, and therefore here e raised to x into e raised to x, that is e raised to x bracket square minus 1 upon e raised to x, again whole divided by, again taking here the addition of these two fraction, that is e raised to x into e raised to x, that is e raised to x bracket square plus 1 upon e raised to x. Again simplifying this, e raised to x and e raised to x become cancelled. Only remaining is, that is y equal to cos inverse of e raised to x bracket square minus 1 upon, in the denominator is e raised to x bracket square plus 1. Okay, that is our given function. Now here we have taken again minus 1 have to be taken outside the bracket in the numerator, and therefore we can get y equal to cos inverse of into bracket minus into bracket 1 minus e raised to x bracket square upon 1 is taken to be first term, that is 1 plus e raised to x bracket square. Again that function have to be written in the form of y equal to cos inverse of, again into bracket minus, again whole bracket 1 minus e raised to x bracket square upon 1 plus e raised to x bracket square, only taking the minus out of the bracket. Now we have to use the formula cos inverse of minus theta equal to minus cos inverse of theta. Okay, and therefore the given function becomes, that is y equal to minus cos inverse of into bracket 1 minus e raised to x bracket square upon 1 plus e raised to x bracket square. Okay, that is the given function. Now we have to substitute here, that is e raised to x equal to tan theta. Then the given function becomes, that is 1 minus tan square theta upon 1 plus tan square theta, and then we have to apply the trigonometric formula, and therefore that is put e raised to x equal to tan theta, therefore theta equal to, that is tan inverse of e raised to x. Substitute this value in the given equation, that is y equal to minus cos inverse of into bracket 1 minus e raised to x bracket square upon 1 plus e raised to x bracket square. Okay, therefore the given function become, that is y equal to minus cos inverse of into bracket 1 minus tan square theta upon 1 plus tan square theta. Now we have to apply here only formula. We know that is 1 minus tan square theta upon 1 plus tan square theta equal to cos of 2 theta, and therefore the given function become, that is y equal to minus cos inverse of cos 2 theta. Now continue this example. The last step of the given example is y equal to minus cos inverse of cos of 2 theta. Now here cos inverse and cos become cancelled. Only remaining is, that is y equal to minus 2 theta. Okay, that is only remaining. Now again resubstitute the value of theta. We are already discussing, that is y equal to minus 2 into tan inverse of e raised to x, that is the value of, only substitute the value of theta. Therefore, now differentiate the given function with respect to x, we can get the derivative, that is dy by dx equal to, yes, that is minus 2 upon tan inverse of f of x, having the derivatives 1 upon 1 plus f of x bracket square. Here is f of x is our e raised to x, and therefore minus 2 upon 1 plus e raised to x bracket square into, again, derivative of the f of x by composite rule, that is d by dx of e raised to x. We know that the derivative of e raised to x is e raised to x again, and therefore the derivative of the given function becomes, yes, that is dy by dx equal to minus 2 into e raised to x upon 1 plus e raised to twice x. And this is the derivative of the given function. Same procedure here also, only firstly simplifying the given inverse function in the simple form, then apply the substitution, and then again simplify the given function in the simplest form, and then we can get the derivative of the given function. Now, again we have to take the next example of the exercise 1.2, question number 9, type 6, that is the substitution method. Here the given example, fourth example is sine inverse of into bracket 4 raised to x plus 1 upon 2 whole divided by 1 plus 2 raised to 4x. That is our given function. Okay. Now we have to find the derivative of the given function. Firstly, write the given function as y equal to sine inverse of f of x. Here again the given function in the form of sine inverse of f of x. We have to convert that f of x into the trigonometric function. But firstly, again here is also we have to simplify the given function, and then we have to apply the substitution. Okay, here in the numerator 4 raised to x plus 1 upon 2. That means here we have to apply the formula a raised to m plus n equal to a raised to m into a raised to n. By this formula we can get the numerator as 4 raised to x into 4 raised to 1 upon 2. And in the denominator 1 plus again 2 raised to 4x are written in the form of by the formula of indices, that is a raised to m bracket raised to n equal to a raised to m into n, that is 2x into 2, that is 4x. Okay, and therefore we can get y equal to sine inverse of, again we know that 4 raised to x into 4 raised to 1 by 2, 4 raised to 1 by 2, that means root of 4 divided by 1 plus, again here is 2 raised to twice x, again a raised to m into n, that is a raised to m bracket raised to n, and therefore it can be written as into bracket 2 raised to 2 bracket raised to x, again bracket raised to that 2. Okay, again simplify the given function y equal to sine inverse of, we know that root of 4, that is 2 into 4 raised to x whole divided by 1 plus 2 raised to 2, that is 4. That means 1 in the denominator 1 plus 4 raised to x bracket square. And then here in the numerator and denominator we have to get 4 raised to x as a common term. Then we have to substitute here our substitution. Which is the substitution we have to use here? That is, if you have to substitute here 4 raised to x equal to tan theta, then we can get here 2 into tan of theta upon 1 plus tan theta bracket square, that is tan square theta, and then we have to apply the formula, and therefore substitute here, that is 4 raised to x equal to tan theta, then of course theta equal to tan inverse of 4 raised to x, and therefore the given function becomes y equal to sine inverse of into bracket 2 tan theta upon 1 plus, that is tan square theta. Then we have to apply here formula. Do you know the formula? Yes, remind. Do you know formula? Yes. That is 2 tan theta upon 1 plus tan square theta equal to sine of 2 theta. That formula have to be applied here. Okay. And then we can get the given function becomes y equal to sine inverse into bracket sine of 2 theta. And then this is the simplest form of our function. Then here sin inverse and sin become cancel. Only remaining is 2 theta, and therefore we can get that is y equal to only 2 theta. Now resubstitute the value of theta, that is tan inverse of 4 raised to x, and therefore y equal to 2 into tan inverse of 4 raised to x. That is the simplest form of the given function. Now differentiate with respect to x, that is dy by dx equal to 2 into tan inverse of x or tan inverse of f of x, having the formula is 1 upon 1 plus f of x bracket square. Here f of x is our 4 raised to x, and therefore 2 upon 1 plus 4 raised to x bracket square into d by dx of f of x, that is 4 raised to x by composite rule. And therefore again taking the derivative of 4 raised to x, again apply the formula a raised to x equal to a raised to x into log of a. And therefore we can get the derivative of the given function dy by dx equal to 2 upon 1 plus 4 raised to x into 2, that is twice x, into bracket derivative of 4 raised to x, that is 4 raised to x into log of 4 by the formula. And therefore we can get dy by dx equal to, that is 2 into 4 raised to x into log of 4 upon 1 plus 4 raised to twice x. That is the derivative of the given function sin inverse of into bracket 4 raised to x plus 1 upon 2 divided by 1 plus 2 raised to 4x. Now taking the last example of this type, that is substitution method of exercise 1.2, question number 9, type 6, that is the fixed example. The given function in the form of tan inverse of into bracket 2 into x raised to 5 upon 2 divided by 1 minus x raised to 5. Okay, here we have to find the derivative of the given function. Firstly take the given function y equal to tan inverse of f of x. Again here is also out of bracket we have to given the inverse function, that is tan inverse of f of x. We have to convert the given f of x into trigonometric function. Okay, but firstly here is also we have to simplify the given function, then we have to apply the that is the substitution. Okay, and therefore firstly write the given function in the form of tan inverse of into bracket that 5 upon 2, that is 2 into x raised to 5 upon 2 divided by 1 minus x raised to 5 have to be written in the form of 5 upon 2 into 2. Here we have to arranging the terms, that the formula a is to m into n, then here 2 and 2 become cancel, only remaining is 5. Okay, now again this term become, that is y equal to tan inverse of, in the numerator 2 into x raised to 5 upon 2 divided by 1 minus here a raised to m into n, that can be written as a raised to m bracket raised to n, and therefore in the denominator, that is 1 minus x raised to 5 upon 2 bracket square. Okay, now here we are looking, that is in the numerator x raised to 5 upon 2 and in the denominator also x raised to 5 upon 2. Then we have to apply here the substitution. If you have to apply here, then we have to take the substitution, that is that is x raised to 5 upon 2 equal to tan theta. Again, that is theta equal to tan inverse of x raised to 5 upon 2. Then the given function becomes, that is y equal to tan inverse of into bracket 2 tan theta upon 1 minus tan square theta. Again we have to find here the formula. What is the formula? In the last example we are already discussing, that is 2 tan theta upon 1 plus tan square theta equal to sine of 2 theta. But here we have to given 2 tan theta upon 1 minus tan square theta. Then what is the formula? Yes, do you remember the formula? That is the 2 tan theta upon 1 minus tan square theta equal to tan of 2 theta. That formula have to be applied here. Then the given function becomes in the simplest form, that is y equal to tan inverse of into bracket tan of 2 theta. Again here, then we can get tan inverse tan here become cancel, only remaining is 2 theta. That is the simplest form, and therefore we can get that is y equal to 2 theta. Again resubstitute the value of theta, therefore y equal to 2 into tan inverse of x raised to 5 upon 2, because we have to already find the value of theta equal to tan inverse of x raised to 5 upon 2, and then we can differentiate the given function with respect to x, because we have to convert the given function in the simplest form, then we can take the derivative, and therefore dy by dx equal to, again we have to apply only the formula of tan inverse of f of x, and therefore we can get dy by dx equal to 2 upon 1 plus x raised to 5 upon 2 bracket square into d by dx of x raised to 5 upon 2. Okay, then simplifying this step, that is only taking the derivative of x raised to 5, that is we have to apply the formula x raised to n equal to n into x raised to n minus 1, and therefore the given function, and here in the denominator 2 can become cancel, and therefore we can get that is dy by dx equal to 2 upon 1 plus x raised to 5 into derivative of x raised to 5 upon 2, that is 5 upon 2 into x raised to 3 upon 2. Okay, therefore again simplifying this, dy by dx equal to 5 into x raised to 3 upon 2, here 2 and 2 become cancel, only remaining in the numerator 5 into x raised to 3 by 2 upon 1 plus x raised to 5. Again here the given function can be written in the form of x raised to 3 by 2 written in the form of 1 plus 1 by 2, therefore we can write that is dy by dx equal to 5 into x raised to 1 plus 1 by 2 whole divided by 1 plus x raised to 5. Again by the implementing the formula of indices, that is a raised to m plus n equal to a raised to m into a raised to n, that means it can be written as dy by dx equal to 5 into x raised to 1, that is x, into x raised to 1 by 2, that is root of x, divided by 1 plus x raised to 5. Okay, that means dy by dx equal to 5x root of x upon 1 plus x raised to 5, only simplifying the given function. Okay, and that is the derivative of the given function tan inverse of into bracket 2x raised to 5 upon 2 divided by 1 minus x raised to 5. Okay, here is also firstly simplifying the f of x in this form, then applying the substitution, then applying the substitution we have to get the simplest form, and then taking the derivative we can get the derivative of the given function. Okay, that means in all the examples same method, only we have to firstly simplify the given function, then in the form of when you have to apply the formulas of the trigonometry. Okay, that substitution and that simplification is very important. Okay, do you understand all these 5 examples? Okay, thank you.